Welcome to the KickStart series for MEDIC-MRCOG Part 1 on the topic Diagnostic Accuracy Tests, especially Sensitivity and Specificity. Myself, Dr. Avinash SS, one of the mentor in the areas of Biostatistics, Research Methodology, Teaching, Learning and Assessment at StudyMRCOG. Today, we will see what are the tips and tricks to solve some of the questions related to biostatistics as well as diagnostic accuracy tests. So basically, we need to give a very simple read on each topic and then solve the questions from each topic. Then we need to identify learning issues on those topics. Once we identify, we need to go and do the study and understand and memorize the concepts and definitions and formulas which are related to the topic. Then come back to the question, analyze those questions, translate the words in the questions into solvable data, apply the learnt formula, and then solve the questions. Later, you can self-reflect and solve more questions. This is like the steps to any self-directed learning. Then what are the actual things, more tips and tricks to solve sensitivity and specificity questions? One thing is, for solving questions related to sensitivity and specificity and other related diagnostic accuracy tests, we need to understand the definitions of these diagnostic accuracy tests like sensitivity, specificity, positive predictive value, negative predictive value, likelihood ratios, etc. Then we need to read the question carefully. Once we do that, we need to translate the data into a 2x2 table, which is very, very important. We will learn further how to do that. Then the 2x2 table should be comprised of what is the true positive number, false negative number, true negative number, as well as the false positive number, and the totals on the rows and columns. Then we have to use the formula which we have understood using the concepts to calculate some of these diagnostic accuracy tests, which we will learn in our next series, next slides of the KickStart series. Now, what are those diagnostic accuracy tests? So which are those diagnostic accuracy tests? There are many. One is sensitivity, which is also called as you can see there, it is also called as true positive rate. What is this sensitivity? We will study later. Then the other diagnostic accuracy test is specificity, which is also called as true negative rate. The other diagnostic accuracy test is the positive predictive value. And then the negative predictive value, the likelihood ratio, positive as well as negative likelihood ratios. All these are the diagnostic accuracy tests. Now, what is the sensitivity? Now, sensitivity is the ability of a test to correctly detect those with a disease. Specificity is the ability of a test to correctly detect those without a disease. Positive predictive value is the probability or a chance that a subject who have tested positive are truly having a disease. Negative predictive value is again a probability that a subject who have been tested negative truly does not have a disease. Likelihood ratio of the disease in those who tested positive. We'll learn further what are those. Similarly, the likelihood of no disease in those who tested negative are called as negative likelihood ratios. These are simple definitions. We will understand and try to understand further. Look at this diagram here. These are false negatives. These are true positives. These are false positives and these are true negatives. Then what is the sensitivity? What is this sensitivity? Now sensitivity is the probability of a test to be positive in those with the disease. What is the probability of the test to be positive in those with the disease? Whereas it can be calculated using this formula, that is true positive divided by true positive plus false negative. Then what is specificity? Specificity is the probability of a test to be negative in those without disease. Then how do we calculate this? It is true negative divided by true negative plus false positives. So how many true negatives are there out of true negative and false positives? That is called as specificity. Now when we look at this double bump chart, you can see if some test which is having a cutoff value upon which we are deciding whether the test is positive or negative, right? Such a test, if it is 100% sensitive, suppose the test is 100% sensitive, you can see the cutoff value will be A. Cutoff value will be A. Now anything above this is always, or anything below this level is always negative. That means if an 100% test is negative, you can definitely rule out the disease, and this can be remembered as sensitivity out, SNOUT. Whereas if a test is, let us say, 100% specific, then the cutoff value usually will be C, and anything above that is always positive. Then if that 100% test is positive, then you can rule in the disease. You can remember it as specific rule in the disease spin. So to reiterate, a 100% sensitive test is negative, you can rule out the disease. A 100% sensitive test is positive, you can rule in the disease. Now let us try to understand the definitions of diagnostic accuracy test one by one. If the test is positive and those also has the disease, it is true positive. If the test is negative and they do not have the disease, is true negative. Now if the test is positive, they do not have the disease, it is false positive. And the test is negative but they have the disease, is false negative. Now what is sensitivity? Sensitivity, which is also called as a true positive rate, is those who are having the disease, how many are tested positive? That is true positive by true positive plus false negative. Hence it is called as true positive rate. Now what is specificity? Those who are not having the disease, how many are tested negative? That is true negative by true negative plus false positive. It is also called as true negative rate. Now what is the positive predictive value? Those who are tested positive, how many are having the disease? That is true positive by true positive plus false positive, which is also called as positive predictive value. Then what is negative predictive value? Those who are tested negative, those who are tested negative, how many are not having the disease, which is called as a negative predictive value. That is true negative by true negative plus false negative. Now we will see what is prevalence. Prevalence is those who are having the disease, that is true positive plus false negative. How many are having the disease compared to everyone out of all the total population, which is true positive plus false negative plus true negative plus false positive. Now, what is this likelihood ratio positive? Now, if you write sensitivity by specificity, if you write sensitivity by specificity and instead you do 1 minus specificity, that is you write sensitivity by specificity, here you do 1 minus specificity, that is negative positive likelihood ratio. So what is sensitivity? Sensitivity is true positive rate. What is specificity? Specificity is actually true negative rate. 1 minus specificity is false positive rate. So likelihood ratio is the ratio of true positive rate by false positive rate. That means the chance that those who are having the disease are tested positive compared to those who are not having the disease are tested positive. This is likelihood ratio positive. The more it is, the better is the diagnostic accuracy test. If you want to know more about how much is better, how much is not good, please do subscribe. What is negative likelihood ratio? Again, you write sensitivity by specificity. Instead, you do 1 minus sensitivity. This is negative likelihood ratio. Now, what is the sensitivity? Sensitivity is true positive rate, whereas 1 minus sensitivity is, it is not true negative, it is false negative rate. It is false negative rate. What is specificity? True negative, true negative rate. So since denominator is true negative rate, numerator is false negative rate, right? Now it is the ratio of false negative rate to true negative rate. What is this false negative rate means? Those who are having the disease yet tested negative compared to those who are actually not having the disease are tested negative. I will repeat, those who are having the disease are tested negative, false negative, divided by those who are not having the disease are tested negative, true negative rate. The lower is the negative likelihood ratio, the better is the diagnostic accuracy test. Try and calculate the relationship between prevalence and predictive value. Look at this graph here. As the prevalence increases, the positive predictive value will increase. And as the prevalence increases, negative predictive value will decrease. Whereas the sensitivity and specificity will always remain constant regardless of prevalence, because sensitivity and specificity are inherent to the test and not affected by the prevalence. Now, if you want to understand what is the implication of this on clinical utility, do subscribe to our group, StudyMRCOG group. We will further be elaborating this later there. Now, what is this receiver operating curve? This is one more important topic. ROC means receivers operating curve. ROC means receivers operating curve. What does it plot? It plots on the y-axis, that is sensitivity, that is the true positive rate, and on the x-axis it plots 1 minus specificity, that is the false positive rate. The less is the false positive rate and more is the true positive rate, the better is the diagnostic accuracy of the test. The curve will be something like that at each cutoff values. At each cutoff values it will be plotted. Now, when it is indeterminate, it will be like this curve. The diagnostic accuracy of such test is worthless. It is a 50% chance that it is right, 50% chances it is wrong. It is worthless. And you can see in between is actually for good diagnostic accuracy. So, receiver operating curve plots the true positive rate against the false positive rate, and area under this curve will actually give us the total diagnostic accuracy of the test. To understand further about the receiver operating curve, do subscribe to our StudyMRCOG group. Now, let us see how to solve some of the problems. Now, here we'll see prevalence of thrombosis in cases of severe PIH in a tertiary care unit was 10%. So, prevalence was 10%. Now, total population screened was 1000. See, N is 1000 here. Total population is 1000. A novel test detected the thrombosis in overall 185 women. That means test was positive overall in 185 women. It was positive. We don't know whether it is true positive or false positive, both. However, only 95 were actually having thrombosis, means only 95 were having the disease. What is the sensitivity? Now we have understood this. Let us put that into the 2 by 2 table. So how to put that into 2 by 2 table? This is on the row columns, thrombosis, disease positive and disease negative. Now prevalence is 10%, means 10 out of 100 are having thrombosis. Whereas that means here total population is 1000. So the total 10% of the 1000 is 100. So 100 out of 1000 are having the disease total. Now, how many are having the test positive? Total 185 are having the test positive. As it is given in the 185 are having the test positive. Okay. Now, what else is given? Only 95 were actually having thrombosis. Amongst those who are tested positive, only 95 are actually having thrombosis. Then what is the remaining people? It is 90. These are false positives. Those who are having the test positive and thrombosis positive are true positives. Those who are having the test positive and thrombosis negative are false positives. Now we filled many columns. Now we will see another problem. Now if 185 are tested positive out of 1000, how many are tested negative? It is 815 are tested negative. Now we will fill the columns. So out of 100, if it is true positive, 5 will be false negative. The total is 100. Out of 900 remaining, 90 are false positive, means 810 will be true negative. So this is how we fill the columns and rows of a 2 by 2 table after understanding the questions and the definitions of the formula. Once we fill this, look at the up to down arrow. What is that? In those who are having the thrombosis, how many are tested positive? That is sensitivity. That means true positive by true positive plus false negative. Here it is 95 out of 100. So sensitivity is 95%. Now the next question. Prevalence of thrombosis in this case again is 10%. Prevalence is again 10%. But total population again is 1000. For the ease of calculation, we are keeping with the same values. Okay. Now sensitivity is given here. Sensitivity of the new test is found to be 95%. It tested positive in 90 women who did not have thrombosis. What it gives? It tested positive in 90 women who did not have thrombosis. That means it is false positive in 90 women. Sensitivity is 95%. Now they want us to calculate specificity. Now let us put this into 2 by 2 table. Thrombosis positive and negative. Prevalence is 10%. This we already know. 100 out of 1000 are having the disease. So 10%. If 100 are having the disease, 900 will not be having the disease. This we already know. Then sensitivity is given 95%. What is the sensitivity? Those who are having the disease, how many are tested positive? In those who are having the disease, how many are tested positive? It is 95%, means 95 out of 100 having the disease are tested positive. That means we have to fill the 95 out of 100 tested, those who are having the disease are tested positive. So once we fill that, what else is given? If tested positive in 90 women who did not have thrombosis, that means it tested positive in 90 women who did not have thrombosis. This is false positive. Once we have this, we have to fill the column. So how many will be tested positive? False positive plus true positive will be 185. If it is 185, those who are tested positive, how many will be tested negative? 1000 minus 185 is 815. Once we have this, we get this. How many are tested negative? That is 5 false negatives. And how many are true negatives? That is 810 true negatives. By adding and subtracting and knowing the columns. Here what did we know? Here we knew sensitivity, and here we knew false positive. How many were false positive? Based on that, excuse me, you can find out the specificity. How? Look at the down to up arrow. How many were tested negative in those who did not have the disease? In those who did not have the disease, how many were tested negative? This is true negative rate. That means true negative by true negative plus false positive. How many were tested negative? 810 out of 900 tested negative. Out of 900 without disease tested negative. So its specificity is 90%. So this is how, using two known values, we can calculate the other. Now one more test we will see, question we will see. Here again, for the ease of calculation, prevalence is 10%, same. Sensitivity is given. Sensitivity is 95%. Specificity is also given 90%. The rest they want us to find out the positive predictive value and negative predictive value. Now what do we do with this now? Here we have to presume some number as n. For the ease of calculation, we will presume 1000 as the total number of population, because we don't have the data here. That is why. Now if it is 10% is the prevalence, 10 out of 100 will be having disease. So how many out of 1000 will be having disease? 100 out of 1000 will be having disease. So now we have presumed the n as 1000. You can presume any other numbers. For the ease of calculation, we have presumed that 10% means 100 will be having disease. That means 900 will not be having disease, right? Now what other information we have? We have the information that sensitivity is 95%. That means 95 out of 100 will be true positive, because it is a true positive rate. So now we another thing we have, 95 are true positive. 95 are true positive out of 100. So how many will be false negative? 5 will be false negative. Another information we have, that is the specificity. How much is the specificity? 90%. That means 90 out of 100 will be true negative. 90 out of 100 will be true negative. What is the 90% of 900? It is 810. If 810 are true negative, the remaining 90 are false positive. Now we can see we have filled all the 4 cells in the 2 by 2 table. Now you calculate positive predictive value. What is positive predictive value? Those who are tested positive, how many are having the disease? That is true positive by true positive plus false positive, which is equal to around 95 out of 185, 51.3% is the positive predictive value. Negative predictive value, look at the right to left arrow. What is this? Out of those who are not having the disease, how many are, out of those who are tested negative, how many are not having the disease? 810 do not have the disease out of 815 who are tested negative. True negative by true negative plus false negative. It is around 90% is the negative predictive value. So you can see, once we know 2 to 3 aspects here, sensitivity, specificity and prevalence, we can calculate the positive predictive value, negative predictive value by just filling the table and understanding the concept. Now here we will see few things we already give, but how to calculate likelihood ratio. Now again, the prevalence was 10%, total population is given 1000, true positive were 95, true negative was 810. What is the likelihood ratio positive and what is the likelihood ratio negative? We'll see how to fill this. What information is given? 10% information is given, right? Right. Now, how many are having a disease here? 100 out of 1000 are having the disease, right? 10% prevalence. True positive, that means 100 are true positive plus false negative. This 100 is true positive plus false negative, right? So how many of this is true positive? Out of 100, we already have the information, it is 95, so we fill it 95. Then the remaining are false negative. Similarly, how many are true negative? We have the information 810, the remaining is 90, so we fill this information on the 2 by 2 table. Once we fill the information, you can see that you can calculate sensitivity. So it is 95 out of 100, 95%, and you can calculate specificity, which is true negative rate, which is 810 out of 90, as we have calculated earlier, it is 90%. Now we have calculated both sensitivity and specificity. Using this, you can also calculate the positive and negative predictive values. Then how to calculate likelihood ratio? So positive predictive value, 95 out of 185, and negative predictive value is 810 out of 815. Now how to calculate likelihood ratio, right? So likelihood ratio, positive is sensitivity divided by 1 minus specificity. What is sensitivity? The sensitivity is 95%. How much is the specificity? 90%. So 1 minus specificity is 1 minus 0.9. So it is 0.95 divided by 0.1, which is equal to 9.5. So you can see it's almost near to 10, which is a very good diagnostic accuracy test. Likelihood ratio is better. Now what is likelihood ratio negative? It is 1 minus sensitivity by specificity. So it is false negative rate by true negative rate. Do we have the 1 minus sensitivity? No. Using for sensitivity, we have to calculate it. If sensitivity is 95%, so what is this 1 minus sensitivity? It is around 0.05. That is a false negative rate. Specificity, we already know it is 0.9, which is equal to 0.05. If the lesser is this negative likelihood ratio, the better is the diagnostic accuracy test. Now you can see, using some of the informations in the question and understanding the concept, we can write the 2 by 2 table and calculate the sensitivity and specificity, positive predictive value and negative predictive value, and also the prevalence likelihood ratios, positive and negative likelihood ratios. So this is how we solve these diagnostic accuracy tests. Understanding the definitions are very important. So to know more about what is pretest probability, how to calculate the pretest odds using pretest probability, how to calculate odds using probability. Now, how to calculate post-test odds using pretest odds and likelihood ratio positive. How to calculate post-test probability using post-test odds, and what is the utility of likelihood ratio. Now such questions are also asked. Means before doing the test, what was the probability of having the disease? Now after doing the test with a particular sensitivity and likelihood ratio, what is the probability of he having the disease. Of course, it will increase. Now, how to find out, right? It depends on the likelihood ratio of that particular test. The more it is, the more is the post-test probability of having the disease. So if you want to find out more how to solve this, do subscribe to our Study Medic group. You will get a lot of videos, podcasts, preparatory videos, and flashcards, revision notes, mock tests, and a whole lot of reference materials and resource libraries. And we cater to many national and international courses. Apart from this, you can see MRCOG, MRCPI, etc. all are given, and a 2-year clinical and non-clinical programs are also available. So contact on the following numbers and do subscribe. Hope this KickStart series was very helpful. Thank you. All the best.